Today's lesson is 12.8, adding mixed numbers. The objective for today is that I will use models and computational procedures to add mixed numbers. The first thing that we're going to be looking at is this problem right here, which says Andrew uses 1 3/6 cups of whole wheat flour and 1 4/6 cup of buckwheat flour in his recipe. How much flour did he use in all? Solve in any way. Well, when we are looking at this, we're going to use this visual to help us. In your notes, I would like for you to go ahead and write down our two mixed numbers that we're working with. So we have 1 3/6 and 1 4/6. Well, looking at my visuals here, if I continued these parts over here, I would have another row completed if they were divided into 6. My 1 whole represents this blue portion. The 3/6 represents the orange portion I have here, which is how I know that those are all 6. Down here, same thing. The orange portion represents my 6, and the blue portion represents the 1 whole. So he wants to know how much flour he uses total. Well, so now I'm going to take a look at both of the rows, and I want to add them all together. Well, again, if I had completed this, I had that completed, that 3 of these would fit into up here, which would give me another whole. So I would have 1 whole, 2 wholes, 3 wholes, and just 1 portion left over. So my final answer would be 3 1/6. Taking a look at this next problem right here, you can see another visual for how we actually add our mixed numbers. So I have 2 3/12 and 1 10/12. So I'm going to start by adding together my whole numbers. So 2 plus 1, I'm going to start by doing that, and I'm going to end up with 3. I'm going to go ahead and add 3 plus 10, which would give me 13, and my denominator, which is 12. So I add together my wholes, and I add together my fraction. The only problem is when I look at this, I automatically know, based on one of my previous lessons, that 13/12, that is an improper fraction. I cannot leave an improper fraction with a whole number like I have here. So for just a second, I'm going to leave my 3 alone, because it's my whole number. That means I have 3 complete sections. So I'm going to leave that by itself. So I'm going to work with 13/12. Well, we worked with this before, and we figured out that if I were trying to figure out my improper fraction as a mixed number, I start by figuring out how many times the bottom number goes into the top number. Well, if I have 13, I take away 12 of those, I would have 1 left. My denominator won't change. So again, the way that I figured that out is I did 13 minus whatever was on the bottom, and then I wrote what was left over right here. My denominator did not change. But now my final answer is not 1 1/12. I have to take this and add it to my 3. So I would actually have a final answer of 4 1/12. So we're going to do that differently. So go ahead and write these down in your notes. I want to complete these together. So we have 2 7/8 plus 1 3/8. So I'm going to write that out like this. 2 7/8 plus 1 3/8. Well, again, I like to add my whole numbers first. So 2 plus 1, which will give me 3. My denominator is the same in both parts, so I'm going to keep that the same over here. 7 plus 3 would give me an answer of 10. But again, I cannot leave my answer like that. So I take 3 10/8. And now I'm going to try to break that down a little bit. Leave my 3 by itself for a minute, and I focus on this. Could do my long division like I've done before. So I'm trying to figure out how many times the bottom number can go into the top number. Well, I know that 8 goes into 10 one time. If I subtracted 10 minus 8, I'd have 2 left over. Well, based on what I've learned about changing improper fractions to mixed number, that leaves me with 1 whole. There's 2 left over out of my denominator of 8. So I'd end up with an answer of 4 2/8. At this point, you would have the opportunity to either leave it like this, or I could even simplify even further, because if I look at 2/8, I know that I can divide both the top and the bottom by 2. So I would end up with 4 1/4 as my final answer. If you left it like this, I would be okay with that. But if you can, I would love to see you try and simplify even further. With you are working with these types of fractions and you're adding and eventually subtracting them, you are going to realize that there's a lot of little steps, but if you focus on one step at a time, I know you can do it. Let's try our other problem, which is 6 5/12 plus 4 11/12. When I see 11/12, I already know I'm really close to one whole, so I'm probably going to have to do what I've done before on this one too. But again, add my whole numbers first. 6 plus 4 gave me 10. 5 plus 11 would give me 16/12. But again, I don't want to leave it like that. So I take what I know, which is, I know that 12 is going to go into 16 only one time. So again, leaving my 10 alone for a minute. So it's going to be one whole. Then I have to subtract the 12 from 16 to give me what's left over. Well, I also automatically see that 4/12 is going to be able to be simplified because I can divide both the top and the bottom by 4 to give me my new fraction of 1 3/4. But again, not done yet, because I then have to take what I know here and add it to my original whole I got when I added 6 plus 4. So I'll end up with 11 3/4. If you ended up with 11 4/12, I would again accept that answer. We're working towards being able to identify when we can simplify problems. Go ahead and complete number 1 and number 2 in your notes and have them ready to go.